In this video, let us learn about isotopes. So this is what we usually see for carbon. As we have discussed earlier, this number here is the atomic number which is designated Z, and this is the mass number which is designated A. Okay, so please remember that the atomic number gives us an indication on the total number of protons present in the nucleus of the atom. So carbon with an atomic number of 6 has a total of 6 protons in its nucleus. Now this one is the mass number. So mass number is equal to the total number of neutrons and the protons. It's equal to the total number of protons plus neutrons. So mass number is 12. We know that it has 6 protons, and this also has 6 number of neutrons. That's how carbon is designated as carbon subscript 6 and superscript 12. Okay, now this is what we know. However, in nature, carbon can exist in 3 different forms. So these are the 3 different forms in which carbon can exist in the nature. Okay, so if you look here, the atomic number which is designated by Z is common for all the different forms of carbon. So the first one has a mass number of 12, and this is the example that we have studied earlier. It can also have mass numbers of 13 and 14. Okay, so if we see here, the total number of neutrons are different between these 3 forms of carbon. Okay, so this one has 6 neutrons, this has 7, n refers to neutrons, this has 8 number of neutrons. Always remember the total number of protons will be the same, and that is equal to the atomic number. Okay, so these 3 forms of carbon only differ in the total number of neutrons. That's why their mass numbers are different. Okay, so now what exactly is a isotope then? So isotopes can be defined as atoms of the same element with different mass numbers. Okay, so isotopes are atoms of the same element with different mass numbers. So in this case, these 3 forms of carbon can be designated as isotopes because all of them have the same number of protons, but they only differ in the total number of neutrons. Okay, the most common form of carbon, which is this one, has 6 neutrons, but carbon can also exist in nature with 7 neutrons and 8 neutrons. Okay, so these 3 forms are called isotopes, and they should be of the same element. Let's look at another example. So let's take the case of chlorine. So chlorine is designated capital C small l. The atomic number of chlorine is 17. So we have 2 different forms of chlorine. Okay, again remember this is Z, and this is your mass number which is designated by the letter A. Now if you see these both forms of chlorine, again the atomic numbers are the same as is expected because the total number of protons will always be the same. Okay, now let's look at the mass number. The first form of chlorine has a mass number of 35. So the mass number which is designated A is equal to the total number of protons plus total number of neutrons. So 35 equals 17 plus x. Okay, so now if we do 35 minus 17 equals x, and this is equal to 18. Okay, so this form of chlorine here has a total of 18 neutrons. Okay, this form of chlorine has a total of 18 neutrons. If you do the same thing for this form, so if you substitute 37 instead of 35, then you would end up with an answer of 20, which means that this isotope of chlorine has a total of 20 neutrons. So these both can be considered isotopes of one another because both of them are atoms of the same element and only their mass numbers are different. Okay, so chlorine 35 and chlorine 37 are isotopes of one another. Let's look at one final example. Look at this example. Let's take carbon 6, 14, nitrogen 7, 14. Okay, now if you look at this example, they are not isotopes. They are not isotopes in spite of having similar mass numbers. The reason being, one element is carbon and the other element is nitrogen. Okay, so for two forms to be considered isotopes, their atomic numbers should be the same or they should be the same element. So here we are considering carbon and the other element is nitrogen. Because their atomic numbers are different, they cannot be considered isotopes of one another because they are atoms of different element.